Hey, what's up everybody? This is Ray and welcome back to our beginner OpenGL ES and GLKit video tutorial series. In this part of the series, you'll learn how to take 3D models from 3D modeling tools and import them into your OpenGL apps. Let's start by taking a look at what the app will look like when you're finished with this part of the series. There are many different ways to import your models from a 3D modeling tool like Blender. Let's go through three of the most popular ways. First of all, you have a full access to a Python scripting library inside Blender itself. Using the Python scripting library that comes with Blender, you can access all of the vertex information such as their positions, their normals, their texture coordinates, and so on, and you can write a little script to export that into whatever format you would like. The advantages of this is you have full control over Blender and basically can do whatever you want. The disadvantage is you've A, got to learn this Python scripting library for Blender, and B, you're tied to Blender at this point, so it wouldn't work if you wanted to use a different 3D modeling tool instead. Another way is 3D modeling tools like Blender commonly export to this common file format called the Collada file format. And this is a very powerful format and it has access to everything. It keeps track of the scene graph, it can handle animations, anything that's in the 3D modeling tool can be represented inside this Collada data file. The problem is the data file is in a XML format, so it's a big file, and you wouldn't want to parse these directly in your app most likely because it would take time, processing time, to load these when your app starts up. So usually what you want to do is read in that Collada file and export it into a smaller binary form so your app could run a little bit faster. And actually it turns out that the SDK that comes with iOS to work with OpenGL has its own file format called the POD PowerVR file format. And this is basically a small binary representation of things. And then there's a tool that you can use to convert from Collada to the POD file format, and there's some C++ code you can use to work with these. And this is actually what Cocos 3D, which is an open source game library, does. So the advantage of it is you're using standard file formats, using the standard Collada format, using the standard POD file format. The disadvantage is now you have a little bit more of a tool chain issue. You got to export to Collada, run it through this tool to get the final files. The third option is the simplest option, so that's what we'll be focusing on this video tutorial. It's also a great learning experience. And it is the simplest format that you can export your 3D models in is the OBJ file format. This is literally just a text file. It's really easy to look at, really easy to understand. So you can read in this file and with your own tool and then export the data in whatever file format you want. Now, it's easy for us just to make a header file and a .m file with all the RWT vertex information because that's what we've been working with the entire time. So we can write a tool that reads in those OBJ files and exports the vertex information in the exact way that we like to work on it in our app. There is one disadvantage to using the OBJ file format, and that's it's limited. It can't store everything in your scene. It only really represents one object, and it doesn't store things like animations or different lights in your scene or anything else. So it's really just for storing model information, but for the purposes of this video tutorial, and we just want to bring in a model into our game, it's perfect. Here's what the OBJ file format looks like at a high level. First of all, there's a model. There's one OBJ file per model. So we're going to have a mushroom model that we're working with. And inside that, it might be made up of one or more objects. So if it was made a certain way in the 3D modeling tool, we might have one object for the mushroom itself and one for the stalk. Then there could be more than one material for each part of the object. So the mushroom might have different materials for the top and a different couple materials for the bottom. Remember that the OBJ file format is just a human-readable text file. So this is what it looks like. So for each object, you say O and the name of the object, and then you just list out all of the vertices, all of the texture coordinates, and all of the normals. Now, there's no relation between these yet. They're just literally every position and every texture coordinate. Then later on, when you list out the materials, this is where you associate them into triangles and associate a vertex to a texture coordinate to a normal and so on. So what this means is F, 3 sets of numbers separated by slashes, another 3 separated by slashes, and a third set separated by slashes. So each of those sets represent one vertex and represents the information for that vertex. So there's a position, a texture coordinate, and a normal for each of these vertex. And these are just indices into the arrays of positions, texture, coordinates, and normals earlier. And the set of these three vertices make up one face or one triangle. So actually, not only does your 3D modeling tool export an OBJ file, but it also exports an MTL file which has information about the materials. So for each material it says new MTL and gives the name of the material, and then it gives some properties about that material. And this includes some coloring information such as what ambient, diffuse, and specular color are going to be on this material. This sort of influences how much the light affects this material in different ways. It also has a way to set the shininess, just like you learned about in the specular video tutorial earlier. And the most important part is you can associate a texture with a material. And you can actually associate different kinds of textures to different components. But for the purposes of this video tutorial, we're only going to be worrying about the diffuse texture, which is basically, you can think of as the main texture for this material. In the resources for this video tutorial, I provided you with a Objective-C program. It's a Mac app that reads in these OBJ files and exports them out to headers and .ems that we can use inside our app. I'm giving you the source code for this. Is actually not very complicated at all, and you can feel free to look through it and understand how it works. But I wanted to give you a high-level overview of what's going on here. So there's really two steps for how this program works. The first thing it does is it literally just reads in that file and converts it into an Objective-C representation of that file. So there's a couple different objects that are related here. So the highest level object is the model object, and that just lists out the name of the object and the array of all of the vertices, texture coordinates, and normals that it just literally reads in from the file. Then it has a list of a couple model object parts, which is another Objective-C object. This has an object that stores material information that it reads from the MTL file, and a list, an array of vertex information. And this is that index of the vertex, texture coordinate, and normal that it reads from the OBJ file. Given all of this information, step one is just reading it into a nice structure. Then we're going to run a separate algorithm to generate a header file and a .m file from this information. So we can loop through all of these indices that are in the vertex info structure and look them up in the list of vertices and texture coordinates and so on, and come out with a header and a .m file. So here's what it would look like. So at the top here, you see that there is a list of 420 mushroom vertices. And in the .m file, you see that we've just listed out all the appropriate information that came from the .obj file. So we have a position, a color, which is actually always going to be set to 1 in this case, a texture coordinate, and a normal. And this all came from the obj file. Then we can make our own subclass of the RWT model class that uses this vertex array that came from the obj file rather than having to hard-code it in like we've done for the cube.
Okay, so here we have our app where we left it off in the last tutorial. We have texturing, we have lighting, but right now we have a hard-coded cube model. It would be nice if we could use a model that came from a 3D modeling tool like Blender instead. So let's go ahead and do that. Well, before we do that, we actually have a little bit of cleanup work to do. I don't know if you noticed from the lecture, but the vertices we get from the OBJ file, they don't have any sort of indexing associated with them. And right now we're using index drawing right here. Well, we want to sort of go back to order drawing because that's the way we're going to get the vertices from the OBJ file. So I need to convert my cube class here and my model class to use order drawing again instead of index drawing. And all that means is I have to repeat some information here. So the first triangle is going to be 0, 1, 2, and the second one's going to be 2, 3, 0. So I just need to copy 2 and 0 here. And to prove what I'm saying, if you just scroll down and look at the indices here, you have 0, 1, 2, 2, 3, 0. And the rest of them follow the same pattern. We have 4, 5, 6, and we have 6, 7, 4, and so on. So I'm just going to go through and clean up these to be that way. All right, once I've done this, I don't need these indices anymore, so I'm just going to go ahead and delete that. And I won't pass in them here anymore as well, obviously. So then I need to go to the model class, and I need to modify the initializer here no longer to take the indices or the index count. And similarly, we don't need an index buffer or an index count instance variable. Modify the signature here as well. Get rid of that index count, and get rid of this generate index buffer thing. And everything else stays the same, except down here we're no longer using GL draw elements, we're using GL draw arrays. The mode is going to be GL triangles, and we're starting at index 0 and we're going up to vertex count. So we're back to order drawing again. Now let's get rid of RWT square because I don't feel like updating that. We're not really using it anymore. And back in the view controller, I'm going to delete all references to RWT square. Okay, so I'm running, and it's working just as before, but now we're using order drawing, so we're kind of prepared to switch over to using the OBJ file format. Okay, so I want to show you in the resources I'm providing you with the OBJ loader code. And this is what the project looks like. So you can see here are the classes that I mentioned in the lecture. There's the model object, which contains an array of vertices, texture coordinates, and normals that it reads in from the OBJ file. Then it contains a list of model object parts. These contain some material information that it reads in from the MTL file. And it also loads in some vertex information. The vertex information is really just to index into those arrays that are all the way back here in the model object. So what this does is it reads in the OJ file into those parts. And then this is the sort of the most interesting part of the code here. It goes through all of the vertex information in the model object parts and looks up inside the appropriate array based on that index, and now it has the appropriate position, texture coordinate, and normal, and then it just writes a line out into that vertex, into the .m file with all the vertex information. So it's in that RWT vertex info structure that we want to work with. And that's really it. So I've also provided in the resources a mushroom object. This came from the beginning OpenGL, the beginning Blender video tutorial. And there's an MTL and an OBJ file, and also the mushroom texture that's sort of mapped to all of these vertices. So we want to run this OBJ loader on this mushroom file here. So if you go ahead and build this app with Command B, one of the things it has as a post-build step is it will generate a copy of the OBJ loader binary and put it inside your home directory just for convenience. So I've opened up a terminal here. And you can see that the demo resources contains the mushroom folder. So we can just run obj loader, which has been copied to our home directory, and run demo resources mushroom, and then we give it the name of the obj file, which is mushroom.obj. And you can see here, if it works, it spits out the information about where it found everything and where it's going to be generating the mushroom.h and mushroom.m. So if I open this folder again, I have two new files here for the mushroom.h and mushroom.m. So hold on. I'm going to shut down this. Got my other project open again. I'll just drag in those two files into the Hello OpenGL project and make sure to copy them in. Before I forget, I'm going to go ahead and delete these because we don't need them anymore. They're in our project. Okay. So let's take a look at them. So this contains some information about the ambient, diffuse, and specular lighting to apply to this material and the shininess too. We're not actually going to be using this in this part of the video. It will be in an Uber Hacker Challenge, but for now, we're going to be using the default lighting properties that we've already set up, and what we will be using is this list of vertices here. And the list of vertices is just the RWT vertex structure. This is similar to the stuff we just hard-coded in the cube class, except this is coming from the OBJ file, which of course comes from Blender. So we don't have to figure all this out. We just let Blender do it for us. And this is the position, color, texture coordinate, and the normal for this first vertex. And these first three, that's triangle number 1. This next 3 is triangle number 2, and so on. So to use this mushroom header file and mushroom.m file, it's actually very simple. We're just going to create a new subclass of RWT model like we did for the cube, but we're going to be using these vertices instead. So I'm going to create a new class, and it's going to be called RWT mushroom, and it's going to derive from RWT model. Then in the .h, we're going to take a standard initializer. Switching over to the .implementation file, the first thing we'll do is we'll import that header file that was generated for us by OBJ loader that contains all the vertices. And now let's implement the initializer here. We'll call it mushroom, pass in the shader, and for the vertices, we're going to cast as RWT vertex the data that comes from that header file, which is mushroom, cylinder, mushroom vertices. For the vertex count, we can get that the typical way, where we do size of that structure divided by size of the first element in that structure. Okay, we have to load the mushroom texture using our load texture command. And I forgot to add that into the project. So let's go ahead and drag in mushroom.png into here as well. And so we're going to load in mushroom.png as our texture. And it turns out the mushroom is oriented in a different way than we want it to show up in this app. So we got to set up some rotation here to get it to show up the way we want. We'll also scale it to be a little bit smaller. And last but not least, just for fun, we'll make this thing rotate so we can see all sides of it. Okay, so our mushroom class is done. We just need to modify RWT view controller to use this instead of the cube. So let's just replace all instances of RWT cube with RWT mushroom. And that's it. If I build and run, check it out. We now have a nice mushroom. And this is a little too high, so I'm going to move things down a little bit just with a -1. And there we go. Nice 3D mushroom came from Blender.
All right, that's it for this video tutorial, and as always, we'd like to leave you off with a challenge. So we have actually another video tutorial series that shows you how to use Blender, and the challenge in that video tutorial series is to generate your own tree and your own sword. Well, your challenge in this one is to take those models that you might have done in that other video tutorial and import them into your OpenGL ES app. So we were actually provided for you the actual OBJ and MTL files that came from Blender if you don't want to go through that series. But if you do, you can feel free to make it yourself too. And then your challenge is to go ahead and add them into your app. We also have a more advanced challenge for the Uber hackers out there. So I hope you enjoyed this video tutorial. Thanks for watching, and we'll see you next time.